G'day. In this video, we're going to look at how to create encrypted messages and decrypt messages that you can use to send encrypted messages to your friends and have them send you encrypted messages. And you'll be able to decrypt. You'll be the only one who'll be able to decrypt messages they send you, and they'll be able to decrypt messages you send them. Let's get into it. This video is going to take a little bit of time to go through, but we're going to go pretty quickly. And we're not worried too much about how pretty our software is going to look. We're more worried about the functionality today. We might fix it up and make it look a bit better and work a bit better in another video. But for today, we're just going to make it work. Okay, so we've got to do a few things to start off with. The first thing we've got to do, we need a new folder. So this is my new folder here, encrypt messages. That's what I'm going to call my new piece of software. And inside that folder, I need two other folders, two subfolders, public keys and secret key. Or you can call that private key if you want, because we're going to use public private key encryption or asymmetric encryption to do this work today. So once you've done that, you've created those folders, we need a new file. So I'm just going to call it encryptmessages.py, and that's where I'm going to write my code. Before I start writing any code though, we need to use one module, one external module we have to get from the Pip library, the Pip repository. So I'm going to open a terminal window in VS Code, and you can see that I'm using a virtual environment, my .bit virtual environment, so that appears at the front of my line in my terminal window. So on Windows, I'm just going to type pip install, and the library we're using is called cryptography. Okay, pip install cryptography. If you're on a Mac or a Linux machine, you'd type pip3. Okay, so pip3 or pip, depending upon which operating system you're using, install cryptography. I think I've already got it, so it's not going to do anything, but those are the three things that it'll install: cryptography, CFFI, and PyC parser, if you need them. Once you've done that, you've got those installed, you're ready to go. We don't need any other libraries. So let's get started. First thing we're going to do, quick comment. So just to say what this file is for, what this app is. So this is an app to encrypt and decrypt messages. Okay, simple. All right, now in this app we need to do a few things, but let's just start off basically. So we'll just start off with our standard Tkinter application that we're going to make. So we'll go import Tkinter as TK, from Tkinter import TTK. We'll just do that. We'll go down the bottom of our file and we'll put in the standard code that we're going to use. So we'll say if underscore underscore name underscore underscore equals double underscore main double underscore. That's our idiom, which is going to run if we're running it as a script. So we'll do that. So we'll go root equals tk.capital TK. We'll create a TK application, and then we'll go root.main loop. Okay, and I think if we run that, we should just get a little window. Okay, good. So that's the first thing we're going to do. So we're going to make this application user class, and our class is going to be a frame. So let's create a class. We'll call our class the same name as our file, except we'll call it encrypt message. Yep, same thing, that'll do. Encrypt message, and from here we want tk.frame. No, we want ttk.frame, just in case we want to style it. Okay, that's our class that we're going to use. Then we better define the init function. So double underscore init double underscore. In the brackets we do self, comma, and we want the master object. Because it's a frame, we need to tell it what its master is or what its parent is. So we do that, we put a colon on the end, and the first thing we're going to do is we're going to say self.master equals master. So we remember that that's our master or the parent of this frame. And then we want to call the base class. So we go super with parentheses dot init, And in the brackets, we want master equals self.master. Okay, and that's just going to turn it into an actual TK or TTK frame by calling this line here the super line. Okay, and I think we'll just put in our standard two functions that we tend to use. So we'll configure the interface and we will create some widgets. So we're doing self.create widgets. Okay, so those are just two functions, just so it's not all in the one big chunk of code. We're just, making our code a bit easier to read and easier to manage. So let's just define those functions. So we've got configure interface with self in brackets, self or in parentheses, and we'll just put pass in there for the moment so that it won't give us an error. And we'll do the same thing for the create widgets. Define create widgets. We'll fill these in later. Self colon on the end. Pass is the only thing we need. And now that we've created our class, we can actually use it down the bottom. So we've created our root object, which is our TTK object, and now we can add the frame. So we will just call this one, well, we'll just call this frame, and we'll call it encrypt message, and the master is the root window. So we'll do that. And then we better make sure it displays. So we'll do frame.pack, and just with brackets there is fine. Parentheses is fine. Save that. Double check that it works again. Yep, it sort of works. Doesn't do anything because we haven't put anything in the frame, but we've got a little window. Okay. All right. Now we're all set to go. Okay, so let's get started on the main part of our application. So we need to use a few extra modules. We're using Tkinter stuff, but we need to use a few more. First of all, we're going to use the file dialog from Tkinter. So let's get that in first. And we're using the file dialog, and we're going to use the ask open file name, that one. We're going to use that dialog box in our code. All right, now we need a few more things. So we need the OS module, so we import OS. We also need the Base64 module, so we're going to import Base64. Okay, and then the last two things that we need have come from our cryptography library, the one that we installed using Pip, I should say. So the one we installed down here in our terminal window, this one. The one we installed using Pip, we're going to use this library. So you have to install it with Pip first before you'll be able to make this code work. So we're going to go from cryptography. There it is, because I've got it installed, it shows up. And it's a little bit funny, but we need hazmat, and then we need primitives, and then we need asymmetric. So it's a bit long, cryptography.hazmat.primitives.asymmetric. And we need to import two things from this library. We're going to use the RSA algorithm and some padding. Okay, so that's what we need from that library, but then we need to do it again slightly different. So we go from cryptography.hazmat.primitives, and we don't need the asymmetric this time. So we just do .primitives, and then we go import, and we want serialization and hashes. Don't worry too much about what this stuff all is. We're going to use it, but you don't really need to know what it is. But effectively, this is just going to do our encoding and decoding, or our encrypting and decrypting, I should say. Okay, so we need these things to do the encryption and to decrypt our text or our things that other people send us. Okay, so we've got all the libraries we need, all the modules we need. Now what we need to do is start creating our class. So we added these two functions here, the configure interface and the create widgets, but we're going to need other ones. So let's just put them in for the moment without filling them in, without worrying about what's inside them. So we're just going to define some more functions. So we'll call the first one get public key list, because this is going to give us a list of all the public keys that we have. So all our friends' public keys. And we can use those to encrypt messages and send them to our friends, and they'll be able to decrypt them, but only they'll be able to decrypt them. So the next function we need is one that's called the private key function. So we want load private key with self again, and we just keep putting pass in. And then we need one called load public key, because there are two keys when you use asymmetric encryption like this. The public key, anyone can know. You send that to your friends and they use it to send you messages. But the private key, you don't want anyone except yourself to know. So you never share your private key. That's the one you keep just for yourself. That's your super secret private key. Public key, anyone can have it, doesn't matter. All right, so now we want a couple of functions. One to decrypt messages. So we'll call it decrypt message. And then we want one to encrypt message. So we want to be able to decrypt and encrypt messages. So we'll have those two functions. And yeah, I think just for convenience, I think we'll add in this function. We'll call it, yeah, we'll just call it copy encrypted message. Whoops, if I could spell. Encrypted message. This one's a pretty simple little function, but it's just like a convenience function. We'll keep that one. And the last one, to use our public and private keys, we have to be able to generate them. So we need a function to generate some keys, which you'd only really probably do once, but we want to be able to do it as many times as we need to. So we'll just create a function for it. Okay, I think that's all of them. I don't think we need any more. So we've got, let me get rid of this shell. We've got our configure interface, create widgets, the list of public keys that we know, our private key, loading a public key, decrypting and encrypting messages, copying the message, and generating our keys. Yep, that looks good. I think that's all of them. Okay, we can start filling in some code then. All right. So, well, we'll start at the top. Let's start with this one. Configure the interface. Okay, so here we're going to put in a few variables to remember, sort of like config variables, I suppose you might call them. So let's start with these ones. Self.private key. We're going to create a variable to save our private key, and we'll just set it to none at the moment because we don't know what it is. And we'll do the same for public key. None is just like a value that we don't know what it is, so we'll just set it to that. And I'm going to set a key name, which is just like a convenience for what you want your keys to be called. So for me, that's going to be mutable learning. I might even put a dash in there instead of an underscore. There you go. So my keys will have that. So in other words, when I send my public key to someone, to my friends, so they can use it to encrypt messages and send them back to me, they'll see that it's my public key. It'll have my name as the key. So it's just for saving us having to type it in different places. And then this is an important one. We want this one. We need the path. This is just to help us type less as well. So we're going to use the OS module. And the OS module helps us do things like find files and work with locations of directories and files and that listing files and all that kind of stuff. So we're going to use the path.directory name command, but inside that we're going to use it again, os.path, but this time we're going to use the absolute path. And it's the absolute path for this file that we're typing in now. So that is going to tell us where this file is on the hard drive of this computer, and it's going to store its location in the self.path variable. So we won't have to keep looking for it, and we'll be able to use it to create other files or the path to other files anyway. Okay, done. I think that's enough for our configure interface. That should be good. All right. Ooh, now we're on to what should we do next? You know, I think rather than doing the create widgets, that's going to take a lot of time because we've got a fair bit of stuff to put in there. Let's go down and do this one. Let's generate some keys. Let's do this one, the generate keys file. So when you use asymmetric encryption or public-private key encryption, you create a pair of keys. One is the public key and the other is the private key, and they go together. So we don't have any at the moment, and we need to put them in these folders. So we need to create our public and private key. Mainly the private key is what we're concerned with, but we also need a public key to send to our friends. So let's create them now, or let's set up the code to create them. So we'll go our key, and this is where we're going to use the RSA module that we imported from the cryptography library. So we're going to use that, and we're going to use this function called the generate private key. And that's going to create our key for us. And we need to give it some information. So it needs a public exponent. And it's best to just use this value, 65537, which I think is a prime number. So I think that's a good value to use. You can use other ones, but that's the one we're going to use. And then a key size is how secure you want your private key to be. The bigger the number, the better. But we're going to use 2048, which is kind of like the smallest safe one. Any smaller than that, and it could get compromised. You could use 4096 or even larger numbers, but we'll just stick with 2048. So we'll just go with that one. Okay, that's enough to create a key. With that line, with those lines of code, or with that function, generate private key, we've created a private key. So how do we get our public key? Well, the public key is just one that's created from the private key. So our public key equals key.public key. And that's going to give us the other key with our pair. We've got our private key, and now we're going to have our public key, and they go together as a pair. All right, so, but we don't want to just store these in memory when our code runs. We don't want to create, new keys every time our app starts up. We want to save them somewhere. We want to save them in files in these directories, have them as actual files. So to do that, at the moment, these keys aren't like text data that we can easily work with. So we need to turn them into text data that we can then save in files. So to do that, we make what we call PEM or PEM files, I suppose you might say. So let's create our private one first. So we've created our two keys. Now we need to create the data so we can save it in our files. So we'll call this one private PEM. That's going to be the data. And we need to use the key private bytes function this time. So this is the bytes of our key. And we need to give it an encoding. And this is where we're going to use the serialization module. And we need encoding and we need PEM because we're turning it into a PEM file. And then as well as the encoding, we need to give it a format. And we use a serialization again. This time we use, private format and traditional OpenSSL. That's what we want for that one. And finally, we're going to use an encryption algorithm, and we're just going to say serialization and .no encryption and put parentheses on the end of that one. Okay, so it's a bit long, but hopefully you can find all those. Using the tab key to automatically finish typing those function names will save you a lot of typing as well. So start typing the name like Syria, and then as soon as you see serialization, just push tab. Okay, that's our private PEM file or not file, that's our private PEM data created. Now let's save it to a file. So before we can save it to a file, we're going to tell it what the file's path is. So we want to save it in this secret key folder. So let's just create that as a whole path, the whole file and path name together. So we'll call it the private key file. This is going to be the actual file that we're going to create. And we're going to make this an F string because it's just a string at the beginning. So we're going to say self.path, which is that one we created earlier. And then we want to slash, and mine's called secret key, that secret key folder. So that's where I'm going to put it. Secret underscore key, another forward slash, and then we want our self.key name, which is the one that I put mutable learning in. So that was my key name, so I don't have to retype it. And we want to make sure we highlight that this is the private key, and we want .pem on the end. So that's going to be the name of our file. It's going to be the path with our secret key subfolder, and then mutable learning -private, or whatever you put in up here. If you put in your own name up here, then that's going to be inserted down here. All right. Okay, so that's our file. Now all we need to do is save this PEM data into this file. So we just go with open, if I can type, with open private key file, comma, and we want to do RB, we're writing to it as a binary file, and as private with a colon on the end, and then we just need private dot write and tell it to write out the private PEM data. Okay, so we're writing this data into this file. That's what those two lines of code are doing. Taking that data that we created, putting it in this file, the private key file. And we're done. And we just need to do the same kind of thing for our public key. So we've done the private, now we need to do the public. Now the public key doesn't need quite as much stuff, but it's pretty much the same thing. So let's do public PEM equals our public key dot public bytes. So you can see we're not doing private stuff now, we're doing public stuff. This time the encoding is the same thing. Serialization, encoding, dot encoding with a capital E, dot PEM. And we only need a format, serialization again, public format, dot public format, dot. Now this one is subject public key info. So it's slightly different, that one. That's it. So, whoops, we've already got our parentheses there. There we go. So we only need that for the public PEM. And then we do the same thing as before. We create our public key file, but this time we don't want to store it in the secret key folder. We want to store it with the other public keys. It's our public key, but it's still a public key, so we want to store it in a different location. So we're going to do public key file. And we'll just say file there. And this one equals F string again. We want our self.path. And we want that. And this time we want public keys. And this one is going to be just called self.keyname, because this one is just my public key. And then we need .pem on the end. Done. That should give us our key file for our public key, and then we just need to write to it. So with open public key file, comma, WB as public, colon on the end, public dot write. And what do we want to write? We want to write the public PEM. Public.pem, public underscore PEM data. Here we go. And that's it. Okay. Now that function, if we run it, that function will generate a private and a public key for ourselves. It will save the private key in this folder, and it will save the public key in this folder. And then we'll be able to start encrypting and decrypting messages if we wanted to, but only for ourselves. So that's a good start, but we can't really use this function easily at the moment. We need to actually start creating some of our interface to be able to use this function. So yeah, I think let's go start doing that. So we're going to start creating some widgets. Now there are quite a few widgets that we need to create because we basically need to load our key files, public and private ones, and then we need to put in text to encrypt or put in the encrypted text to decrypt. So we need, a fair few widgets to do. Not too many, but a few. And I think for this application, we're going to use a notebook. We're going to use the Tkinter notebook, which is kind of like a tabs. We're going to use tabs. We're going to have a tabbed window. So let's start creating some of these widgets. So we'll start off with the tabs, I think. So we'll start off with, and I'm just going to call it tabs. And we're going to use this notebook. And it's going to belong in the frame. So we put self as the master. All right, and then we just pack it. But we're packing it, and we're not just packing it. We also really want to expand. We'll say true or 1. We'll just put 1 there, and we'll fill it. tk.both. Okay, so we'll do that just to make sure that it stretches out to the full size of the frame. And what do we need to do? So there are, I might just put a quick comment in, say use a notebook to show some tabs. All right, now before we can use the tabs though, we actually need to create the stuff that's going inside the tabs. So we're basically going to have 2 tabs, one for encrypting and one for decrypting. So we need sort of the widgets that go in each of those tabs. So I guess we'll create 2 frames, a frame for encrypting and a frame for decrypting, and inside those frames we'll put our widgets. So let's create the, well, I guess we'll create the decrypting frame first. So let's just write a quick comment, frame for decrypting messages. So this is when someone sends you an encrypted message and you want to decrypt it using your private key. So let's just create our frame. We'll call it self.decrypt, ttk.frame, and it actually belongs to the tab or the notebook widget. So we have to tell it that its master is self.tabs. So this frame belongs to self.tabs. And we may as well give it a width and a height. So we'll say width is, well, let's just say, I don't know, 550. That'll do. And we'll say, actually, let's make the width a bit wider. Let's make the width 650 and the height 550. Oops, equals. Okay. All right. So that should be enough for the frame, but we'll add the widgets into the frame before we lay it out. So let's add in our first widget. We've got our frame. So the first thing we want to do when we decrypt messages that someone sent us is we need to load our private key. So we've got our private key saved in a file here, and we want to load it, and we want to store it in this self.private key variable. So let's create a button to load our private key. So we'll call it self.load secret. It's a secret key. Doesn't really matter. You can say load private key, whatever you wanted, and we'll make it a button. And for this button, I think it belongs to the frame, so self.the decrypt frame. And also, what do we need? It's a button, so we need some text. And the text for this one is going to be load private key. Okay, and the command. So when we click the button, the command that it's going to run is our self.load private key function that we created right there, load private key. So there we go. So that function is going to load our private key. We haven't created it yet, but when we fill it in, it'll load our private key. Okay, so we've created the button. We better add it into the frame. So I think we'll use a grid for this. I think we'll use a grid. Self.load secret. There it is. .grid. Yeah, it'll be easier with a grid. So we'll go row equals 0, column equals 0, and we're going to have, how many columns are we going to have? We're going to have 2, so we'll set this one to sticky. We'll move it over to the right hand side of the first column. So we'll say sticky equals tk.east. That'll put it on the right hand side of its cell. Okay, and just to give the user to give us some visual feedback that we have actually loaded a key, let's put in a quick message. So we'll put in a status message. So we'll go self.private key status, and we'll make this a label. It's just a label. It's just going to change when we've loaded our private key. So we'll go self.decrypt as the master, and text by default is going to say not or no key loaded, whatever, no private key loaded. There we go. So that's going to be the default text that it tells us, and we need to show that one. So let's do self.private key status .grid. This is going to be on the same row, so row 0, but one column across. So column 1. And we're going to use sticky, and we're going to make this one to the left-hand side of that column, so west. There you go. So they'll appear next to each other. All right. So we've done that, and I think what we need now is, once we've loaded our key, what we then need to do is, someone's going to send us an encrypted message. So we want to copy that encrypted message and paste it into a text box. So we need a text box to paste in the encrypted message into. So let's put in a text box under the button to paste in our encrypted text. We'll call it text because this is the, take that space out. The encrypted text is what your friend sends you. They send you an encrypted message, and we're going to decrypt that. So this is going to be a text box. So tk.text, there's no ttk.text. So tk.text, and it's going to be self.decrypt, because that's the frame that it's in. And we don't want it being too big, so we'll give it a height of 15 lines, something like that. We'll try that. And we better put that in the grid. So this is the encrypted text dot grid, and this is going to be row 1, column 0, and we'll make it span across the columns. So we'll say column span equals 2. All right, so that's the encrypted text box. Next, we need a button. So you've pasted your message in. Now you need a button to click on so you can decrypt the text. So we've got our encrypted text pasted in, or typed in, however you want to do it. Probably pasting is going to be a lot easier. And then you want to be able to decrypt it. Need a button. So let's go self.decrypt, decrypt, and we may as well call it button, ttk.button. And self.decrypt is the master. Then the text is decrypt message. Let's just call it text. Decrypt text. That's it. And we need to give it a command. So the command equals self dot, and we already created the function. It's called function for this one was called decrypt message. So that one there. There we go. That's this function down here, which we're going to fill in again at the end or a bit later. Okay, so we've got a button. We better put it in the grid. Self.decrypt button.grid. Row. This time it's another row down. So we'll go row equals. What one did we get to? We got to 1. So this is going to be row equals 2. And we'll put this in column 1. I guess we may as well, no, not column 1. We want column 0, don't we? Because we want it in the same one as the first button. So sticky equals tk.east. There you go. That'll help them to line up a little bit anyway. So we've got our encrypted text. We've got a button to decrypt it. So now we need somewhere to store the decrypted message so we can display it and see what it is, see what the person has actually sent us. Okay, so self.decrypted message. So this is after you've decrypted the message, this is where it's going to stick it, the data or the text. So tk.text again. And this one is still self.decrypt, and height, we'll set it for 15 again. Okay, and add it to the grid. So decrypted message.grid, and we want row equals 3 this time, and column equals 0, and column span equals 2. Right. Oh, and we may as well, down the very bottom, I mean, we've got to put it somewhere. We need to run this function at least once to generate our keys. So let's put it down the bottom here. So let's just add in one more button down the bottom here to allow us to generate some keys. Yeah, I think we may as well put it in here. Okay, so self.generate key pair. Yeah, ttk.button, self.decrypt is the master, text equals, so we're going to say generate public, whoops, I think I'll put a slash there, private keys. Okay, oh, we need the command, don't we? Command equals generate, self.generate keys. There we go. And that button will create some keys for us. Let's click that in a minute. Let's run it and see if it works. Self.generate keypair.grid. That's what I was trying to type there. Finger's not working too well. Row equals 4, column equals 0, sticky equals tk.east. Done. And all we've got left to do now is hack our frame. Yep, we have to put the frame in so the frame is going to display. So let's do self.decrypt.pack, and we'll expand it, and we'll fill it both. There we go. Okay. And since we're using our tabs, we can now create our first tab. So we've created our frame. That should be everything we need for our frame. So now we can just add a tab. So when you create a notebook, you add the tabs once you've got the widgets to put in it. So we've got a widget now, our frame, so we can add the tab. So let's just give ourselves a bit of space, put in a comment, add the frames as tabs in the notebook. All right, so let's add the first one. So we'll go self.tabs.add. Okay, and we need to give it a child, which is our frame. So self.decrypt. And then we just give it some text, which is what's going to appear on the tab. So text equals, and let's say this one is decrypt. So this is going to be our decrypt tab. Okay. Let's see if that works. So let's see what happens when we run our code. Oh, look at that. We've got our window, we've got some buttons, there's a label, these are our text boxes, and a few more buttons. It's not a pretty looking window at the moment, but that'll do. That'll help us. Okay, so if we click on these buttons, not much happens, but this one will actually do something. So I tell you what, let's go look and see. If I expand these folders are empty at the moment, but if I click this button and we haven't got any errors, we should start to see some files appear in there. Let's see if it works. So I'm going to click the button and look at that. We've now got some keys appearing. There's my public key and there's my private key. Okay, let's have a quick look at them. That's what a public key looks like. It's not too long, but a private key is quite a bit longer. That's our secret one, which we never want to share with anyone. That's the one we sort of have to keep a secret for this to work. But this one, the public key, that's the one you just send to your friends. So you just copy that file and send it to them in an email or send it to them in a text message or however you can get it to them. Because it doesn't matter if anyone else gets a hold of it. They still won't be able to unencrypt your messages. They'll only be able to send you an encrypted message. That's all they'll be able to do with it. So that's not a problem. So you keep this one safe, but you send that to all your friends or anyone you want to be able to send you an encrypted message. So that's cool. We've now got 2 keys that we can use. So that's a start. So we've got quite a lot done. So what do we need to actually do? We have to load our private key. And we want to be able to decrypt messages too. I tell you what though, before we do those, let's finish creating the interface. So we've got one half of our interface done. We've got the decrypting bit. Let's do the encrypting bit to be able to encrypt messages, and then we can copy and paste those into chat or whatever and send them to our friends so they can then decrypt them. So we need the other half. We've got the decryption, now we need the encryption. Okay, so, well, we're pretty much going to add in another frame. We've done our decrypting frame. We just need to add in our encrypting frame. So let's put in a little comment. So add a frame to encrypt messages. All right. So the first thing about encryption is when you encrypt a message, you use a public key. So you use a private key to decrypt the message, but you use the public key to encrypt it. So at the moment, I can only really encrypt a message to myself because that's the only public key I've got. But if your friends send you their public keys, you can use those to start encrypting messages and then send them the encrypted message. So what we need to do is we need to load our public keys. And we might have lots of them, one for each person we're talking with. So we need a way to select the public key we want to use. So I think we'll use a drop-down box for that. So let's say you've got 10 friends, you click on the drop-down box, you pick the friend that you want to send an encrypted message to, and then you can encrypt the data using their public key. Okay, so let's do that. So we need a frame. So we're up to the encrypt frame. So we did decrypt, so let's do encrypt. Self.encrypt equals ttk.frame. It belongs to the tab notebook, so self.tabs, that's its parent or its master. And we'll do the same thing, we'll give it the same. Well, let's do a quick copy and paste so they're the same. We'll do width and height, same as the decrypt frame. There we go. And we can start adding in our widgets. So the first thing we're going to want is a combo box to select which public key we want to use for our encryption. So we'll go for self.public keys, I think. We'll just put an S on the end so it's a different name. And it's going to be a combo box, so ttk.combo box. And it belongs to the frame, so self.encrypt is its master. And what do we need for this one? We need some values is what we really need, don't we? And that is where we are going to use this first function down here. the get public key list. So we're going to use that function to actually create the list of public keys that we have. So we don't have to type in anything here. We're going to use a function to do it for us. So we are going to put values equals self.get public key list. And we don't need any parentheses on the end in this case. Oh no, it's not a command. So we do need it because we are actually running the function here. So yes, you do need the parentheses this time. Okay. And well, just in case, imagine you've got a combo box and you click on it and the drop down list appears and you pick someone's name from that list. When you pick their name, you actually want it to update the public key, the one that we're going to store up here. We want to change the public key each time we pick a different public key from this list. So we're going to bind an event to this combo box so that every time we change it, it updates the public key to the new one. So we're going to do self.publickeys.bind, which is how you add an event to a widget so that every time that event happens, the widget runs a particular function or a command, I suppose you might think of it as. So we're going to say combo box selected. So that's the event. This one, combo box selected, that's the event that occurs, and you do need these arrows. So you've got 2 less than symbols and 2 greater than symbols, and combo box selected in between. That's the name of the event that it happens or fires whenever you change or select something different in the combo box, in the drop-down list. So each time you select something in the drop-down list, this event will run. And we already created a function for it, didn't we? I think we called it load public key. So we want that function to run whenever we change the selection in our combo box. So self.load public key. There's our function that we're going to run. Okay, so we've bound an event. Now we just need to add it to the frame, so display it. So we'll use a grid again, self.publickeys.grid. And this one is row 0, column 0. There we go. Okay, so we've got a little drop down to choose our public keys, and we need a message. So where we're going to type in whatever the message is we're going to send to someone, then a button to encrypt the message, and then a text widget to display the encrypted data. We can then copy and paste it into our chat app or whatever it is, our email, however we're sending them the encrypted message. So let's create an area for us to type our message. This is where we're going to type the message to our friend. Oops, that should be a text. And it belongs to the encrypt frame. And we'll stick with the same height of 15. And we'll add it to the grid. This one's going to be row equals 1, column equals 0. There we go. So that's our area to type in our message. Now we need a button to actually encrypt that. So we do self.encrypt button, just so it's a different name. ttk.button. Self.encrypt is the parent again. That's the frame that this button belongs in. And the text for this button is, I guess, encrypt message. That'll do. Encrypt message. And the command equals self.encrypt message. That function, which we're going to fill in. Self.encrypt button grid. This one is going to be the next row down. So row equals 2, column equals 0. So they're all in the same column, but they're just one row under each other. And so now we've clicked our button. Now we want the message that's been encrypted to display in a text box, so we can copy and paste it. So self.encrypted message, tk.text, belongs to self.encrypt, and the height is 15. And put it in the grid. Self.encrypted message.grid, and this one's going to be row 3, column 0. Okay, we're almost done. What else do we need? Oh, the copy button. Yeah, because once you've encrypted your message, you can just use your mouse or whatever to copy the data that's stored in this text box, or we can actually create a little button to help you. So to help us, I should say. So let's do self.copy message, ttk.button. So you don't need this, but it's just a nice, simple thing to add to make things easier for us. So the text is going to be copy encrypted message. And the command is self, whoops, need the command thing. Command equals self.copy encrypted message, that function we created earlier. And oh yeah, we've got to add it to the grid. So self.copy message.grid. This one's going to be row 4. Yeah, I think row 4. Row equals 4. Column equals 0. Done. And the only thing left to do is to add the frame. So we just need to pack our frame. So self.encrypt.pack, and we'll do the expand equals 1, fill equals tk.both. Okay. Oh, and we can add our tab. So we can just add a new tab, copy and paste, except instead of being decrypt, we'll make this one encrypt, and we'll change the text to encrypt as well. Save that, and if we've got everything working, we should now have 2 tabs, and let's see what they look like. Okay, no errors there, so that's good. And we've got 2 tabs, so we've got our decrypt tab and our encrypt tab. Now nothing really happens when we click on these things yet, but at least our interface looks good. All right, so we're almost finished. All we've got to do now is fill in these functions. So how many have we got to do? 1, 2, 3, 4, 5, 6. 6 functions and we're done. Oh, this won't take too long. All right. Oh, I hope you're getting all this working. This is a good effort if you make this work. It's fairly long, but hopefully you'll start to see that you can get a lot done pretty quickly. Let's do the easy function first. So I think the easy one is this one, the copying the message. That's only 2 lines of code. Yeah, because all we need to do is clear out the clipboard and then actually put the data in that we want to put into the clipboard. So we only need self.clipboard clear. So we run that function. So that's going to clear out the clipboard. And self.clipboard.append, and we just need to tell it what to append. So what we need is the information from that text box, the one that we created here, the encrypted message text box. So we're going to get the information from it and put it in the clipboard. So to do that, we just go self.encrypted message, and we use the .get function. Now, when you use a text box, when you use get to get the contents of the text box, you use 2 parameters. 1.0 is the beginning of the data in the text box, and then you can type tk.end to get it until the end. So that'll get us everything that's in the text box from the beginning until the end. So these 2 parameters are like a start and stop kind of thing, whereabouts in the text box to copy. So we're going to use the whole information that's in the text box, so beginning to end. All right, done. Now, 1 function down, 5 to go. All right. Okay, what's the next function? Well, I suppose now we can start from the top. let's start with this one, the get public key list. This is actually a pretty easy function to write too. So when we click on that combo box, let's have a look. When we click on this drop down, this combo box, we want it to list anything that is in this folder, the public keys folder. That is a certificate, so a .pem file. So we want it, so it should list this one, for example, the one that we created. So that's what this function is going to do. So let's finish this function. So the public keys is what we're going to store our list of keys in, and we use the OS module and the list directory function. And again, we're going to use our path, self.path, because that saves us having to type it all the time. And we're going to have to tell it to look in the public keys folder. So the path plus the public keys folder. Public keys, and we need one more slash on the end of that. So that's going to list all the files in public keys. But we probably don't want all the files because there could be anything in this folder. Who knows what could be in here. So we only want the ones that are .pem files. So we're going to check everything that's in this variable after the OS list directory function runs, and we're going to only keep the PEM files. So to do that, we're going to use what's called a list comprehension, which is just like remaking a list, basically. So let's go public keys. So we're just going to recreate the variable equals, and then we're going to turn it into a list, and we're going to say file for file in public keys if the end of the file, so that's -4, that's .pem, to the end equals .pem. So in other words, it's just checking the end of the file name, and if it's .pem, it's going to keep it in the list, and if it isn't, it's going to ditch it. So that means we'll only get .pem files, and then we'll return that. So by returning it, it means our combo box will have that data filled in. Okay, actually, let's test that and see if it works. So let's play, go to our combo box, and if we're lucky, we should see our first file listed there, and it is. What about if we created another file and we just called it test.txt, and we go back and play? Okay, it's not there because it's not a PEM file. Okay, how about if we rename it and make it a PEM file, PEM? Even though it's empty, you know, it still looks like a key file. So let's check and see if it shows up now. And there it is. Cool. So our combo box is showing us only the PEM files. Nice. Delete that file. Yep. Okay. Down to four functions to go. So, well, the next one is the private key. So let's load the private key. Now this is a two-step process. So we have to load this file, which is a PEM file, and then we're going to actually turn it into, well, I guess it's kind of turned into the key straight away. No, we can load it, but what we actually have to do is find it. So this is where we're going to use that ask open file name dialog box, because that's going to make it easier for us. In other words, when we click on this button, we want a nice dialog box, a nice window to appear that lets us find our secret key file, our private key. So we're going to use the ask open file name to do that for us. So let's make that happen. All right, so the private key. All right. So we'll say the private key file, which is going to be the path to our file. And we're going to use the ask open file name dialog to do it. Now this takes a few different parameters. So let's fill some of those in. So the first one we'll fill in is title. and we'll say select your private key. Okay. And then we want to tell it, well, we don't want to have to find the directory every time, so we want it to actually look in this directory by default. So we set up what's called the initial directory parameter, and this is going to use our path, our self.path again. So we use the old f string and self.path, and it's in the secret key folder. So we put secret key. There we go. That should straight away take us to that folder, so we don't have to, find it. And the final parameter we're going to use is we only want PEM files again. So we give it a list, and inside that list we make a tuple, which is an array. We'll say PEM files, comma, star.pem. So it'll only show us the PEM files, and we won't see other files. It's just a filter, basically. Okay, sweet. So in our private key file, once we run this, that's going to, well, actually, let's run it now. So if we run it and we click the button, there's our dialog box. It's taken us to the secret key folder, and it's only showing us PEM files. That's the only one we can choose. So we could click on that, open, and it doesn't do anything yet, but when we click on open, it has saved that file's full path into that variable. So now we can actually load the private key using our cryptography library. So let's do that. Let's load the private key. So we'll say with open private key file. So that's the file we're opening, but we need to read it as a binary file. And we'll say as key file. Done. What are we going to do with it? We're going to save this as our private key. So we're going to now fill in our private key. All right. So we're going to use that variable we created. So we're going to say self.private key equals serialization again. We're going to use a serialization library, and we're going to say load, and you'll see we've got PEM private key. From a PEM file, load the private key. There we go. So we're going to load it using this function, keyFile.read. That just means read the open file, which we saved as a key file variable. And the password, well, we haven't set any password for this one, so we're going to say none. There's no password. You can actually have a password for your private key, which encrypts your private key, but we haven't done that. Well, we're not going to do that. We're just going to leave it as a plain private key. Okay, that's done. And finally, now that we've loaded it, we can change our status. We can update our little label that we created. Oh, where is it? Where's that label we created? That one. We can update this status. So instead of saying no private key loaded, we can update it to something that tells us we've loaded the private key. So we can say self.private key status.config, and we're going to change its text, and we're going to set it to some new things to tell us that it's loaded. So we'll say private key loaded. Okay, now if that works, let's try it out. When we click and show our dialog and then open our private key, that label should change. Let's see if it does. And it did. Private key loaded. All right, and we didn't get an error, so that probably means that we're all good. It looks like our private key file's working. Nice. Okay, we've got the public key and the decrypt messages and encrypt message to go, and we're finished. Okay, and they're not too bad, so we're almost done. So let's do the public key one. Public key one is pretty similar to the private key, just not quite, well, we don't need this last line, but everything else is pretty much the same. So I guess you could make them one function, but we've split them up just to make it easier. So we'll do the same thing, the public key file, ask no we don't need to ask open dialog this time because we're not actually asking for it. We've already put it in our combo box. So we're going to use the one from our combo box. So, which we actually stored. No, this is to store it in our variable. So this is where we're going to store it up here. This is going to store it in this variable. So that's what we're doing. We didn't open our public key yet. We just got its name. Now we're actually going to open it and save it in that variable. So we do need to do the same kind of thing as our private key. So the first thing we need to do is we set the file, which is another f string, using our path again, self.path. However, this time we are using the public keys one, so public keys, and we need to do whatever is in the combo box, whatever's been selected in the combo box. So we go another variable for our f string, self.public keys, that's the name of our combo box, .get, that will get whatever is selected in our combo box. So that'll get the value that's in the combo box. Yeah, that'll do it. Okay. All right. And then we can open it. So we go with open public key file, comma, we need the RB again. We're reading it as a binary file. And we'll just do the old key file. And then we just need to use our cryptography library. So self.public-key equals serialization, but this one's a little bit different. Serialization load m public key, but it doesn't have so many options. It only takes the key file. Equal, whoops, key file.read, I should say. That's all it needs. It just reads the file. For the public key, it doesn't need the password option. And we don't have a status, so we just leave it like that. So we're done. The public key one is done. Okay, 2 to go. The main meat of our application, decrypting and encrypting messages. Decrypting is what we're going to do first. So we're taking a message that someone sends you that's encrypted and we're turning it back into plain text. So we'll call our variable that stores this plain text. Okay. So we use our private key when we decrypt messages. So this is our secret key. That's the reason why we're the only ones who can decrypt the message, because we use the secret private key. Okay, so we use the decrypt function of our private key or method, but the data is encoded. So in order to display it easily for us to read, we're going to use the Base64 library. So we're going to use Base64 dot URL save. And this time we're going to use the decode function, URL save B64 decode. And then the actual information that it's decoding is stored in our self.encrypted text widget. That's where we pasted in the message that someone sent us. So we need to get that message, and we want it from the beginning, 1.0, to tk.end. So that's the text. So in other words, what this is getting, can we run our code at the moment? Yep. So this is going to get the information that we paste in here, which is the encrypted message, and then we're going to be able to click on this button and it's going to run this function and it's going to display the actual message to us. So that's what we're trying to do. So we take that Base64 encoded stuff, that bit there, And then we need to make sure that the message is in the right format. So we need to do something called add padding. And we won't do padding equals, we'll do padding.oeaep. So this is just the way the cryptography works. Don't worry too much about what all this means, we just need to put it in. So we've got a few funky options here. We've got mgf equals padding.mgf, actually we want mgf1, and the algorithm is hashes dot SHA-256. That's the algorithm we're going to use, and we need to put parentheses there. And that's that one finished. So padding.mgf1 algorithm equals hashes SHA-256. So the algorithm here, we're telling it is hashes dot SHA-256. Put our parentheses on the end, and one final option, the label equals none. Okay, and we're done. That will take the encrypted text and turn it into plain text that we can then read. So all we need to do is display it back to the user. So we need to put it into our text box. So let's delete any message that was in there. Decrypted message dot delete. So we might have done this multiple times, so we'll clear it out first. So we'll do 1.0 from the start until the end. So that'll delete anything in the text box currently, and then we'll insert the new plain text. So we'll be able to see the message. Self.decrypted message insert. And whoops, insert. Don't forget the R. And we want it from the beginning, so 1.0. We don't have an end this time, so we just have the actual message. So what do we want to insert? We want to insert plain text. There it is, plain text. That's what we're going to insert. So this value from this variable is going to get inserted into our text box. All right. So we've done the decryption. Last thing to do is the encryption. And it's almost the same thing. It's slightly different because we're not using private keys this time, we're using public keys. Because whenever you encrypt something, you use a public key. Whenever you decrypt it, private key. So let's just make sure that we've actually selected, when we run our code, no, we need the pass in there, otherwise it won't run. So I'll just put pass back and then we'll run it. So before we can encrypt a message, let's make sure that we've actually chosen a public key so that when we click the button it knows which one to use. So we'll do that. We'll go if self.public key. So in other words, if we know which public key we're using, then we can create our encrypted text, which in this case we'll call ciphertext. That's the encrypted version of our message. And so we need to use the public key. So we want public key dot encrypt. Oops. Might do that. Let's make it a bit easier. Okay. So what do we want to encrypt? We want to encrypt our message. Self.message. Oops. Dot get. And this time though, we are going to do the get from the beginning to tk.end. We don't want that in quotes. So tk.end. You can just write end in quotes and it'll do the same thing. But we actually have to encode it. So we're just going to use the encode function here. And we're going to make it UTF-8. That'll just encode it into bytes. Sweet. Oh, we need a comma on the end of that one. And we have to do our padding again. Same kind of thing that we did before. So we're going to go padding.oaep and parentheses, and pretty much, in fact, Yeah, I think we can. In fact, I think we can just copy and paste. Let's just try copy pasting. And we just need to make sure we get the indenting in the right position. I think that'll do us. Yeah, there's no difference in that, so that should be good. Just check your indenting is correct, okay? Because we added in this extra if statement at the beginning of our encrypt. All right, we've done that. We've now encrypted our message into ciphertext. And yeah, we'll stay in the if statement. Now we just need to show it to ourselves in our text box. So we'll do the same thing like we did before. Self.encrypted message. So this is the text box that's going to show the encrypted message. So we'll delete everything that's in it currently. Delete. And should be getting the hang of this by now with text boxes. 1.0 and then tk.end. Okay, and then we'll insert our new text, but we'll have to Base64 encode it. So we'll go self.encrypted message dot insert and 1.1.0, but this time it's better if I do it here, isn't it, like this? If I do that one, yeah, that looks better. This time we want to Base64 encode our data, so we're going to go Base64 dot URL safe encode. And what are we encoding? We're encoding our ciphertext. That's so we can see it in our text box correctly. Otherwise, it'll look like very very unusual characters. So we're going to turn this into things that actually look like text to us. And we need an extra parentheses. Another one. No, because I've got it down here. Should be good. Done. I think that's it. I think we are done. That looks good. Let's have a get rid of that. We've got all our functions filled in. We have indeed. All right, let's test it out. Let's see if it runs. Okay, we've got a window. All right, we've got some keys. Okay, so first of all, let's test out the encryption. So we'll choose our certificate. Look at that, we got an error. So we did forget something. So what did we forget? Oh, I know what it is. It's the event. We forgot an event. When you bind something, when you bind here, like we did to the combo box, it actually sends through the event. And our function, load public key, which is that one, isn't handling that event. So if we look at our terminal window, yeah, it'll say the load public key takes one, which it does at the moment, the self, but it should take two. So we need to go to the load public key, there it is, and we need to put in comma event, because when we bind it, it's going to send it an event. So it needs to handle both of them. All right, so let's check if that works by running it again. Go to our encrypt, select our certificate, no error this time. Okay, that's good. So here's where we type in our message. So this is a secret message. So we've got our message. So let's see if we can encrypt it. And when we do, if it works, something should appear down here in this bottom text box. So we'll click the encrypt message button. Oh, that looks good. We've got an encrypted version and we can actually read it. So how about this copy button? If this works, when we copy, I should be able to go into somewhere like a terminal and paste it. Can I paste in that terminal? No. So where could I paste? Well, we could go down here and see if it worked. Can I paste it in here? Oh yeah, there you go. There is the data. So it did copy and paste. There's our encrypted message. But I tell you what, we don't want to paste it in there. We can actually paste it back in our window. So if we go here, there's our message. Let's try and decrypt it. So if we paste it into here and we click that, we're going to get an error. So you'll see an error appear here, I think. Let's see. Yeah, there's our error. The reason we're getting an error is simply because we haven't chosen a private key. So let's load our private key, this one, the mutable learning private key. There it is, loaded. There's our private keys now loaded. Now let's try decrypting and see if we get the original message, this one. See if it appears. It did. It decrypted our text. So if we change it and we add in some extra lines and we put a bit more, and then we encrypt it again, you notice that every time we encrypt it, it is still changing. So it's not the same every time, which makes it harder for someone to crack our encryption. So let's copy this version, or let's use our button to copy it, and go back to our decrypt window, and we'll have to delete that one. So we'll just paste it in. We might need a new button to fix that up. We might need like a paste button or something. We could add that in later. Okay, so we've copied in. Is it the same one? P-A-U. Is it the same one? P-A-U. Yep, looks the same one. Yeah, looks good. Let's decrypt it and see if it gets all the extra information that we added into our message. And it did indeed. It's working perfectly. Okay, so we've got encryption and decryption. So all we need now is someone else's public key, and we could put their public key in this folder, and then we could create encrypted messages using their public key and send it to them. And as long as they've got our public key, they can create encrypted messages to us and send it to us, and then we'd be able to decrypt those messages, and they'd be able to decrypt the messages we send them. Awesome. So if you've got that working, you've done really well. Ooh, we've got a bit of an error there. We might have to look at that later, but I think that's because I typed in some stuff. All that code has given us a quite functional little application. Doesn't look great. We certainly would want to make it look a bit nicer, but we've got 1, 2, 3, 4, 5, 6, 7 main functions. We've got lots of widgets. We've got some variables, and we've used some modules. So hopefully you've managed to get that working, and you can now encrypt and decrypt messages. That was a long video, but I hope you found that useful. Thanks for watching. I'll see you in the next one.